Hey everyone, in this video we are going to understand what is page replacement and why do we need different types of page replacement algorithms. So let's start. So in the previous video we have discussed what is demand paging and what is page fault. So if you have not seen those videos, you can find the link of those videos in the operating system playlist. The link is in the description below and you can find here in the I button also. So just to review, in the demand paging we understood that let's say if we are having this process, this is having the page table of this process and this is the main memory or the physical memory in which the various pages of this process are kept, and these are the various frames. And this is our secondary storage device. Here we can say this is a hard disk, okay, which actually stores our program, or you can say process. So at different times CPU access or reference the different pages of this particular process. So let's say these three pages, the page number 0, page 2 and page 5, they are kept inside the main memory at different frame numbers, okay, and this mapping of the various pages with the various frames, it is stored inside this page table. So page number 0 is inside frame number 4, page 2 is inside 6 and page 5 is inside 9. So here you can see the page number 0, that is A, is inside frame number 4 and so on. Now let's say CPU asks for a page which is not inside this main memory. Let's say it asks for the page number 4, okay, so page number 4 is E, and here in the mapping we can see this bit is I. So this valid invalid bit, as I told you in the demand paging video, it tells whether my particular page is inside any of the frame inside the main memory or not. So it is showing I means no, there is no mapping. So what will happen? A page fault will be generated, or you can say a trap or an interrupt will go to the operating system, and then operating system will search inside its table. Now this table is prepared by the operating system, and operating system consult this page table whenever the page fault is generated to check which page number is stored inside which block number, okay. So let's say we want to search for the page number 4 of the process 1, okay, let's say this is the process 1. So page number 4 is mapped inside block number 90 inside your hard disk, okay. So operating system will go here and it will check the block number 90 and it will copy this E inside this main memory, right? So inside the main memory, where it should be placed, wherever the space is free inside this physical main memory, this E will be stored there. So here you can see only 3 frames are actually allocated, okay, and the rest of the frames are free. So anywhere, okay, any of the free frame can be given to this E. Let's say E is given to here, then this page table is actually changed or it is updated. So E is mapped to 11, okay, so this 4th is mapped to 11. So I will place 11 and I will say it is valid now, and then CPU will again restart the instruction so that it can again ask for the page number 4, okay. So these were the overview of the demand paging and what happens when the page fault actually occurs. So we saw that there are many benefits of this demand paging technique, or you can say virtual memory. So demand paging, as we discussed, it is one of the technique to implement the virtual memory. Now as you have seen in the old movie of Karan and Arjun, we saw that wherever there is Karan, there is Arjun. Wherever there is Arjun, there is Karan. And the most important thing to note is whenever a page will be referenced for the first time, a page fault will be generated. So let's say E was accessed for the first time, page fault was generated, right? But if it is referenced again, then there will be no page fault. So if we want to increase the performance of demand paging, that means with respect to our page fault, if we want to reduce the number of page fault, we have to see that demand paging performance actually depends on 2 things. What are those 2 things? First is frame allocation algorithm and second is page replacement algorithms. So frame allocation algorithm says that how many frames should be allocated to each process, okay. So let's say we have many processes inside the hard disk and we want to load them inside the main memory. So how many frames should be allocated from the main memory to each process, okay, that will be decided by frame allocation algorithm. Let's say P1 is given 2 or let's say 3 frames, P2 is given let's say only 2 frames, okay, this one and this one, okay. So how it will be decided, on which factors it will be decided that each and every process will be given how many number of frames, okay. So this also actually decide the performance of the demand paging, or it also affect the page fault. Second is page replacement algorithms. So this says that which frame should be replaced whenever there is need. And actually we are going to discuss this in our current video, that what is page replacement and why do we need page replacement algorithm. This we will discuss in the subsequent video after we discussed page replacement and various page replacement algorithm, and we'll see how it actually affects the performance of the demand paging and what are the various frame allocation algorithms. So the very first question is, why do we need page replacement? Let's understand this with the help of example. So let's say we have a process P1 having 4 pages and we have this main memory having 8 frames total, and we have this hard disk. So this process P1 is here inside this main memory. So this process P1 is inside this hard disk, right? Or you can say this is the program. And this is the page table which is showing the mapping between the pages of this P1 to the main memory. So only 3 pages are present inside this main memory, as you can see in this table. And the page number 2 is not loaded inside the main memory. Now let's say if CPU asks for the page number 2, okay, the page number 2, so it will be checked inside the page table. Page table is showing this valid invalid bit as I. That means there is no mapping of this page number 2 to the main memory. So again, page fault will be generated and the OS will search this hard disk. Okay, and what it will do, so it will actually bring back this page number 2, that is C1, inside this main memory. Okay, so here we have the free frames available, right? So we can keep this C1 inside any of the free frame available. Okay, we can keep here, we can keep here, we can keep here, and so on, as we have seen in the demand paging. But now let's say we have a process P2 and this is the page table for P2. So all the pages are mapped inside this main memory. So here I have mapped all the pages inside the main memory, and now we can see the main memory is actually full, right? There is no free frame available. Now let's say CPU was executing the process P1 and now CPU asks for the page number 2. Okay, so page number 2 is asked, but as we can see inside the page table that this page number 2 is not still mapped inside any of the main memory frame, okay, because it is invalid. Now what will happen? Page fault will be generated and again OS will come into picture and this C1 will be brought inside the main memory. But the question is, as we can see, main memory is full. So where this C1 should be mapped? There is no free frame available. Earlier we have the free frame available, but now P2 has taken up the space inside the main memory. So we have the full main memory. Okay, we have no space. So as we can see that we have no free space available inside the main memory. So what operating system will do actually? It will select a page from main memory that will be called as victim page, and it will be saved out and it will be stored inside this hard disk. Okay, and that page will be actually stored inside this swap space, okay, a special area. And after that C1 will be placed in that free frame. So let's say B1 is taken back from here and it is stored for the time period or for temporary time inside this swap space. Okay, so this frame, that is frame number 3, will be free. Now C1 can occupy this free frame. Okay, so this is called page replacement. So what is page replacement? Page replacement means we are replacing a page. Here we are replacing a page B1 with a new page, that is C1. So this is what we have discussed. Why do we need page replacement? So whenever we have no space available inside the main memory to keep the page which we are bringing from the hard disk or the secondary storage, then we have to select a page inside the main memory. Okay, that page will be called as victim page, and we have to replace this page by a new page which we are bringing back from the secondary storage device. Okay, so in our example, this B1 was selected as the victim page and this page was kept inside this swap space for the time period, and then C1 was given this frame number 3 which was made free by replacing this B1. Okay, so finally we understood what is page replacement and why do we need page replacement. So the thing that to note is the need of page replacement arises only when page fault occurs. Okay, that means if CPU have not demanded or referenced or asked for the page number 2, that is C1, then there is no need to bring this C1 from the hard disk to the main memory, right? Then there is no need of page replacement, right? So only when a page is not inside the main memory and we have no free frame available, then only we will be needing this page replacement. Okay, and the main thing is, the first thing is page fault actually give rise to the need of the page replacement. Okay, and before moving forward, just to remind again, page fault is not the only culprit which is actually giving rise to the page replacement. After page fault, if we saw that there is a free frame available, then also we do not need page replacement. That is, in short, we can say if there is a page fault and there is no free frame available, then only we will go to the page replacement and we will apply the page replacement algorithm. Okay, and actually OS will apply the page replacement algorithm. So this is the overall summary of what we have discussed for the page replacement. So here you can see we have the, let's say, F frame. Okay, it is mapped to some page. Okay, so for that it is valid, and for some another page, okay, let's say we have the entry I invalid. So let's say we are given this page table, and let's say for page Y we have this mapping, that is F. Okay, that is, this is the page number Y, okay, which is mapped here. And let's say for page X there is no mapping, that is, it is invalid, it is not inside the main memory. So as we discussed, whenever there is a page fault, okay, the OS will actually find the location of that desired page on the hard disk. Okay, so let's say this page number X was asked and it is not inside the main memory, so page fault is generated. So X will be searched here by the operating system. So let's say X was here. Okay, so what will happen? Let's say this main memory was full. So what will happen? This X will not be directly kept inside this physical main memory. A victim page will be selected. So let's say this F is selected at the victim page by the page replacement algorithm. That means this page Y will be stored inside this swap space on the hard disk, or this F frame will be made free. Okay, so after we have kept this Y here, then we have to change the entry. Okay, this will be set to invalid because this page Y has now moved back to the swap space, right? And now we have to bring this desired page, this X, inside this frame. So now X will be kept here. So now F has the page X, right? So this X is now mapped to the F, right? So this F will be here, and now here it will be valid. Okay, so that means for the new page we have reset our page table, and now our instruction will again start. That is, CPU will again ask for the page number, this X. Okay, the instruction will again start as we have seen in the page fault or in the demand paging video. Whenever we want to keep any page inside this main memory frame, then if there is a free frame, use it. If there is no free frame, then apply the page replacement algorithm to find the victim page or the victim frame. Okay, and this we know we have to update the page tables, and after that we have to restart that process. Okay, so these are the different algorithms. We have the FIFO, first in first out, LRU. Then we have the different versions of the LRU. We have the optimal page replacement algorithm, counting based page buffering algorithms. Okay, so these are the different page replacement algorithms which will come into role here. Okay, here, that is, they will be helping us to find the victim page, which page should be selected from the different pages inside the main memory, so that free space can be created. So actually different operating system may use different type of page replacement algorithm. Okay, some may use LRU, some may use counting based page replacement algorithm according to their design approaches. Okay, and we should also note this last point. Okay, so whenever the page replacement algorithm, any of the page replacement algorithm that we applied, it says, let's say F should be replaced. Okay, it should be brought inside this hard disk. So the question is, should it always be put inside the swap space or not? So here comes the role of the dirty bit. Okay, as we have seen in the demand paging, if dirty bit is actually 1 for this particular frame, okay, for this F, okay, let's say dirty bit was 1, that means this should be brought here inside this hard disk. Okay, but let's say it was 0. So during the page replacement, the X can directly be copied here. Okay, it need not to be F frame or this the page, that is Y, that was kept here, it need not to be copied to the swap space because it was never modified from the first access, because it was never modified whenever it was brought first time inside the main memory. So page replacement algorithm have to take this thing also into picture. So we will be studying all these different algorithms with the help of numericals in our coming videos. Now before ending this video, let me tell you what is the overall expectation from the page replacement algorithm. So page replacement algorithm will actually be selecting a victim page from the main memory so that the space can be freed and the new page can be brought back inside this main memory. Okay, but the victim page should be selected in such a way so that the page fault rate should reduce. It should not increase, right? That means let's say CPU asks for the page number X and it is not inside this main memory and it was told by the page table, let's say. Okay, so X should be brought here, but the page replacement algorithm will first find the free frame. There is no free frame, so let's say B1 is selected here, okay, as the victim page, and it is brought here and X is kept here. Now let's say the next time when CPU asks for a page, it asks for the page B1, okay, and as we can see, B1 is not here inside the main memory, right? So this page table will say, okay, B1 is not here inside the main memory, there is no mapping, right? So what will happen? Again, page fault will be there. So page fault will be there. Okay, what will happen? We will bring B1 from hard disk. Now where it should be placed? Let's say it is placed here. Okay, the A1 is selected as the victim page, so A1 is kept here. Okay, and we placed here B1, right? Okay, now let's say next time this A1 is actually asked, okay, which is actually stored inside this hard disk, right? So what will happen? Because A1 was actually caught as the victim for the page replacement, okay, the previous time. So this time what will happen? This A1 will cause page fault because it is not inside the main memory, and again it will repeat the same thing. Okay, A1 will be brought here and so on. So here one thing you can observe, the page replacement algorithm are actually selecting that page which is actually going to be used in the future. Okay, so the overall thing is, due to this page fault for the new incoming page, it is getting increased. Okay, every time for a new page fault is generated. So this is actually a bad page replacement algorithm which is actually doing such type of thing. Okay, it should select a victim page so that page fault rate for the overall scenario should be decreased. Okay, so we want the lowest page fault rate. Okay, whether we are asking for a particular page for the first time, so our page fault replacement algorithm should manage this main memory, or they should select a victim page so that we should get lowest page fault rate. Okay, and let's say if we are asking again for the same page also, then also as we can see here, the page fault rate should reduce. Okay, so I hope you have understood that what is page replacement and why actually we need page replacement algorithms. Okay, so we will see all the different page replacement algorithm, that is FIFO, LRU and other replacement algorithm in the next videos. Okay, so if you have any question regarding this video, please write down into the comment box, and if you have liked this video, please like and share this video among your friend also. So see you in the next video with the page replacement algorithm with their numericals. So till then, goodbye.